INL is helping to safeguard advanced reactor technologies by leveraging its expertise internationally and domestically. We work with the International Atomic Energy Agency in doing some of their multilateral collaborations where we bring multiple countries together to learn more about nuclear cybersecurity and how that can apply to some of the advanced reactor technology designs that they are looking to implement in their countries or collaborate with other countries to implement. We are also doing bilateral exchanges where we have some of our experts go and do some training or some technical exchanges to talk about best practices that the country has that we can learn from, and also to impart our best practices that we have in the US. Because it's not just a one-way flow of information, we're all learning together as an international community.
These devices that we've created, these devices that we're providing other countries as well as other facilities within the United States, it creates the opportunity for the younger generation as well as the current operators to test ideas out. Test ideas from an attack perspective as well as test ideas from a defense perspective to understand what works and what doesn't work. The first thing that we would do is have them look at the systems that are critical to nuclear functions and then identify the digital systems that are used to enable that functionality. So we would walk them through the camera systems, the access control systems, the sensors that are hanging on the fence lines to help them understand where digital integration has occurred and where the digital dependencies exist within that system.
INL is adapting to the rapid adoption of technology in the nuclear industry by staying one step ahead and developing some of these critical technologies along with industry. So we all know that we have world-class expertise in artificial intelligence, and we're using that in different arenas like digital twins, simulations, and also working in real time to solve some of the issues that we see coming up in nuclear cybersecurity in the real world.
There's so much cool technology out there. There's AI, machine learning, digital twins. And if we don't start laying the groundwork now, we don't start building the digital infrastructures and systems we need in place to get the data we need, then we're not going to be able to deploy those. And so being at the forefront of how do we get the information we need to be able to build high-fidelity digital twins or be able to actually implement machine learning algorithms to predict maintenance or to predict operations or make operations easier for the people actually running the plant, that's a really cool place to be.
What you see behind me here is the nuclear power plant spent fuel pool cooling system, which the INL developed for a flagship IAEA 2-week computer security course. And the goal for that 2-week course was to bring in people internationally from around the world and give them an immersive hands-on experience. Also, we put in some cyber attacks in the system, and we show them not only how the attacks are possible, but also how to mitigate against those things.
A multidisciplinary approach is needed for nuclear non-proliferation because we are looking at solving a very big problem, stopping the spread of nuclear weapons of mass destruction and their associated technology. So we have to work and throw every tool we have at it.
Cybersecurity and safety engineering have arrived at a lot of the similar best practices: design simplification, reliance on inherent safety features, but we need these guys to still talk together. We need them to be able to share information from the safety side to the security side, and cybersecurity needs to be able to share information back. And only when we have that dialogue going, that interface going through things like education and training programs, do we see really, really big strides in not just the cost to secure and operate reactors, but also how effectively they are secured.